something that looked like this, where you had, so we had done these bottom two, and then you should have had arrows that look like this. So why don't you check yours and see if it matches? What my bad handwriting here says, apparently I wrote in the book last year, sum equals 7, the binary number 7. So sum equals 0 or sum equals 1. That's what it should say. So sum equals 0 and sum equals 1. Okay, so now your lab says, did y'all have any questions on those? Anything that you didn't get?
It's an 8,000 class. Holy.
Who, me?
Yes.
Yes.
Damn.
Lab assignments. Does anyone happen to know if this is exactly the same as last year's? Okay. Serial adder, 2 bits. It just means that, if I've already done it, if it was last year's. More type serial adder. Textbook gives Verilog code for mealy type. Write Verilog code for a more type that adapts the mealy to include the following changes. Make the shift registers 5 bits wide. So 5 bits wide. Okay. All right. Okay, so let's see. How are we going to adapt this code? So we have this module serial adder, and it says make them 5 bits wide. So I see the first thing we need to change. What is the first thing we need to change? Our inputs are 7 to 0. How many bits wide is that? That's 8 bits. How many bits do we need? 5. So how would we change this?
4 to 0.
Make it 4 to 0. It looks like it's not exactly the same as last year's, and so if you are looking at my video from last year, it looks like it was maybe a fewer bits last year or last semester. So we need to make these 4 to 0 to make them 5 bits wide. Do we still need reset and clock? Sure, yeah, okay, we need reset and clock, okay. And then we have this thing, output wire, that is the sum. Interesting, I don't remember, I must have looked at this last year, why you would call it both output and a wire. I guess because it's not a reg? I don't know, but how wide does it need to be? 4 to 0. Okay, now we have reg count, and count is 4 bits wide, and we don't know what count is being used for yet, so we don't know how we're going to change that. But if we look down at the bottom, we see if reset count equals 8, else if run count equals count minus 1. So what do you think this count is doing? Where did we see 8 before in this program? The amount of bits. So what do you think count is probably doing here?
resetting the, like, once you're done with the shift, and it goes back to the start.
Right, so we've got these 5-bit numbers, and we're shifting a bit and shifting a bit and shifting a bit, and once we've done that 5 times, we're done. So this count equals 8 is probably going to change. Oh yeah, look, I have this 4 here. It was 4 bits last semester. Okay, so if count is 5, if that's the biggest it's going to be, we have count up here is 4 bits wide. Do we need 4 bits for count? Because the biggest we're going to have is 5. We should only need 3 for that, right? And you're nodding. Other people are not nodding. So why? You're right, but I'm wondering if anyone else can tell me why we can change this, we can change this 30 to 20. Can anyone else tell me why?
Because we're not dealing with any numbers that's more than 2 digits.
Well, 2 to 0 is 3 digits, but it's 3 binary digits. What does 3 binary digits mean? What's the biggest that number can be?
I need to think on that. Oh wait, that's just 8?
Well, the biggest it can be is
9.
7.
Oh, 7.
7, yeah, go the other way. So the biggest you can get with 3 bits is 111, which is 7. So, and we only need to go to 5. But with the one, if you had to go to 8, you had to have 4 bits. So we only need 2 to 0 there. It would probably work with 3 to 0. S, little y, big Y, I'm not sure yet. Wire 7 to 0, don't really know yet, but I'm going to bet that that's going to be 4 to 0. And we need to have 4 states. So in our state diagram that we drew just a minute ago, what did we call our 4 states? Let me type G0, G1, H0, and H1. Those were our 4 states. When there was just G and H, they only needed 1 bit. It was 1 binary bit. But if we have 4 states, how many bits do we need?
2.
We need 2. So we can have, this will be 2 up, so we can make G0 equals 2B00, G1 2B01, H0 2B10, and H1 2B11. I reserve the right to change that if I go and look at the code that I did last year and I've numbered them differently. There's nothing special to these. This is just, it's easier for us to use G0, G1, H0, and H1 because that's how we were thinking of them. So, all right, now, we're going to have to change this code here because this code is designed for a Mealy machine and we have a Moore machine. So let's see if our book can help us out here. Table 6.46. Table 6.46. Okay, so here is, let's see, G0, G1. Hey, look, they named them the same way. Yay, we're good. Okay, so here we have a state assigned table. So if you are trying to have everything complete in your notes or for your lab report, this might be useful information to have, so you don't have to, you can do it yourself, but you can come back and check it. And then it's telling us what our next state is going to be and what our sum is going to be. And so our next state is going to be, so this comes from right here. So if you are designing this, then in your always block, you're going to have a case statement, and your case is going to be based on what your current state is, as well as what your inputs are. And this is how you determine what your next state is going to be. But I don't think I did it this way. Let me see. How did I do it? Hold on. This is certainly a way to do it. Okay, so what I did was, rather than the output, so writing the finding out the value with this, like right here with the exclusive OR and the ands and the ors, that's all real useful if you have to build it from scratch on a board. But the whole point of Verilog is you don't have to tell it what gates to use. It'll figure that out. You can tell it, I just want you to do this based on what state you're in. And so here is all you have to do is, this is the equivalent to what y'all did when I paused it a minute ago and I had you draw the arrows. This is all this is. You're saying based on the inputs that you get, case QA and QB, if you have 0, 0, 0, 1, 1, 0, 1, 1, what state do you go to depending on what state that you're in? So let's see what all we did. Okay, so we have not all of this is going to be the same, because like yours are 5-bit numbers, so these would be 4 here. Your output and your reg will be, your output will be 4. You don't need the 7-segment display. You don't need that. Well, let's just change this. Let's see what we get. Okay, so what did we change? Tell me what we had. These were, was it 3? 4? We don't need seg or an. This will be 4. Our count we did was 2, right? Okay, reg S, that's our current sum. Y and Y, I'm not sure what I was using these for. QA and QB. Not sure what I'm using those for.
I think you did say QA and QB would go 4 to 0.
All right. And I have the parameters set up for our different states. And then I have this shift register. And so I have shift A, shift B, shift sum. So what are these things doing? What am I doing with these? Can anyone tell me? Well, I have another module that does the shifting for me. So this is important. For those of you who aren't paying attention, this part's important. So this shift register, you're going to have a shift register to shift. Now, yeah. So this, what it gives you is our output is Q. So our parameter here, n would be 5, because we've got 5 bits. So our parameter is going to be 5. Oh look, it was actually useful in this case to have that n in there so I could change it. So n is 5. We are going to have four to 0 input R, right? So we're going to have a 4-bit number, a 5-bit number, that's our input. We're going to have a 5-bit number, that's our output. And if L, okay, I will give a shiny new quarter to the first person who can tell me what this module does. Shiny new quarter. And I'm sure I copied it straight out of the book because that's what, I would never use Shift R N E. That's just not my kind of language.
Does it add a new bit to each of the inputs?
It's a good guess, but that is not what it does.
Does it set Q to R at the start, and then after that it shifts all the bits? I honestly can't tell if it's to the left or the right. But
Well, it depends on your ordering. So what do you mean at the start?
Oh, well, I'm looking at the if L, then Q.
So the L probably stands for load.
Okay.
So this is going to be a dual purpose register that can load or shift. So if L is equal to 1, you load. And then otherwise, if E, then you're going to shift. And what is that line Qn minus 1? What's that W?
Is that because it won't know what the leftmost bit would be because you move them all to the right? They'll use an input, so would that be clear before?
So W is, so this is shift right, and so we're shifting them to the right, and we're going to be shifting something in. We have to shift something in. So for the numbers that we are adding together, what we shift in is irrelevant because we're never going to use it. So where are we getting the thing that we're shifting out? Where's that coming out? Doesn't look like we're using it. So we're not using it. I lied, it's not shiny and new, it's actually pretty grody, but it's the only quarter I have, but you do get it. I expect you to spend it wisely.
Not in a machine.
I
This
want to spend it all in one
is
place.
a New York, it's got a Statue of Liberty in it. Yes. Okay, so you have to do the shifting because the shifting is going to be, that's why right here we're only using the zero bit of each of these to add together. What is this s equals 1 doing?
Is that the sum?
That's the sum bit, yep. And then you will definitely have to change this. Let's see, so how would you change this?
We're not doing the 7-segment display, right?
Yeah.
We're not doing a 7-segment display. How are you displaying your output? LEDs?
Yes.
Okay, LEDs. So that should be pretty easy. All you need to do for that is you don't need to have any of this. You just need to map sum to the LEDs. So you'll have sum is, and I probably did that. Let's see. So you'll set your, you'll have your clock, and you'll set your clock to be whatever you're going to set it to be. Have any of you tried to use the debounced buttons? And did they work pretty well? Have you used them?
I'm not, I tried to use them last lab, I got a bunch of errors probably from my code, and I just used regular ones, so I'm not too sure if they work.
Okay, let's see.
Set the right.
U17, that's, U17 is one of the regular buttons, I think.
Yeah, it is 70.
I'll make sure I get you the right code before I leave. Okay, so you'll set up switches for your A and your B. So you'll need A0, A1, A2, A3, A4, and B0, B2, B3, B4. Jill have to have a reset? Yes?
I was adding
You just added one?
one. Yes.
Yeah. Can't hurt to have one. And then LEDs. And so I did the LEDs. I had LEDs for the A and B, and I did LEDs for the sum as well. So all you have to do is map your sum to the LED, and then it'll show it. That's all you have to do. And you don't need the 7-segment display. And let's see. Oh, yeah, so if you look at the code, so I just copied this code pretty much as it was, and then including this shift RNE, I knew I didn't write that myself, and I got that from, it was probably somewhere else in the book. Oh, it's right here. So the page before. So this is the shift RNA. So this is where I got it from. Just copied it straight from here. And then I had this. And so the only thing that I changed from this was changing this to have the 4 states instead of the 2 states, and changing it to rather than using the combinational logic, to use the logic that we used in our diagram to say just like if the inputs are using a case statement. So I thought I was pretty smart when I was looking at the code, and I said no, I wasn't smart. I just copied it. But it seemed to work. So I am happy at this point to either adapt the code that I have on here to match to this year's lab, and we can check and see if it works, or to talk about the project, or to say that we're done, or I can answer any questions you have on anything else. So what would y'all like?
I'm talking about the final.
I'm sorry?
I'm talking about the final project.
The final project? Yeah.
This is about the final.
Yep, sure. Okay. So the way I would like to start talking, let me stop this.